NASA's Voyager 1 spacecraft is the most distant human-made object in space. It continues an extraordinary journey into the stars, far beyond what anyone thought possible. Launched over 45 years ago, it has exceeded every expectation, traveling deep into space where no spacecraft has gone before. This mission has become one of NASA's most remarkable achievements, not just for its distance but for its ability to still communicate with Earth. Imagine a spacecraft flying through the galaxy, powered by technology that's older than a cassette player, and still sending back signals from billions of miles away. Voyager 1 was launched in 1977, and since then, it has helped rewrite our understanding of the universe with one historic discovery after another. Recently, it delivered a discovery so unexpected that it left the scientific community amazed, raising questions that stretch our imagination. Many people now ask, what exactly did Voyager 1 find? And what does this mean for us back on Earth? The mission began thanks to the work of Gary Flandreau, a brilliant scientist at NASA's Jet Propulsion Laboratory, who found a once-in-a-lifetime planetary alignment. This rare alignment, occurring only once every 176 years, allowed a spacecraft to use the gravity of planets to boost its speed and reach distant worlds faster. Instead of a 30-year journey to Neptune, the route would only take 12 years. NASA knew they had to act fast before the chance was gone. In the summer of 1977, they launched Voyager 1 and Voyager 2, just 15 days apart, to take full advantage of this opportunity. At first, the Voyagers were only expected to study the outer planets like Jupiter and Saturn during a short 4-year mission. But they went far beyond their planned course and kept on going, becoming pioneers of interstellar space. The spacecraft captured breathtaking images of the moons of Jupiter and Saturn, revealing volcanic activity and icy landscapes never seen before. Voyager 2 was the first spacecraft to visit both Uranus and Neptune, sending back unprecedented data that changed how scientists view those distant worlds. Even though Voyager 1 is now over 14 billion kilometers away, it continues to send information that helps scientists study the universe. The mission began with a unique gravity assist around Venus, something that had never been done before, and made its way to other planets. Traveling to Jupiter was especially challenging. It had to go through the dangerous asteroid belt and navigate distances 10 times that of Mercury's orbit. And the spacecraft itself had very limited technology. Its computers only had 69 kilobytes of memory, less than most emails today. Despite that, it operated with remarkable autonomy, handling problems on its own and storing data on tape recorders. That data was then transmitted back to Earth using a 23-watt transmitter, the power of a light bulb, through a large satellite dish. As Voyager moved farther from Earth, it took over 18 hours for its signal to reach scientists back home. Radio interference from everyday sources like phones and radios made detecting the signal more difficult, but the mission continued without fail. One of Voyager's most crucial milestones was crossing into interstellar space, the area beyond our solar system, by passing through the heliopause. The heliopause is where the solar system ends and space between the stars begins. At first, scientists expected to see big changes in the magnetic field. But when Voyager 1 crossed this boundary on August 25, 2012, the changes were not what they had predicted. Instead of a major shift in the magnetic field, it stayed surprisingly stable, which shocked scientists around the world. What did change, however, was the level of plasma density, a clear sign that Voyager had entered a new region of space. This unexpected data challenged previous ideas about how space outside our solar system works and how stellar environments interact. The fact that the spacecraft detected this while still functioning shows the incredible durability of NASA's engineering. Voyager 1 and 2 have become symbols of human curiosity, traveling farther than any spacecraft and expanding our view of the cosmos. They have proven that with bold thinking and strong will, we can explore even the most distant corners of space. As they head toward the Oort cloud, a mysterious region filled with icy bodies and comet-like objects, the mission is far from over. The data they collect could one day help us understand how the solar system formed and even how life may exist elsewhere. These probes are still unlocking mysteries we never imagined, from strange particle behavior to the quiet hum of interstellar space. Their journey reminds us that space is vast, mostly unknown, and full of possibilities, and that we're only just beginning to explore it. They continue to send signals, guiding future missions and inspiring scientists and dreamers around the world. Voyager's story shows that sometimes the most powerful discoveries come from missions we never thought would last this long. So as these tiny spacecraft float through the stars, they carry with them our hope, ambition, and endless curiosity. Subscribe to our channel and thanks for watching.